Hello, seventh grade. Welcome to our next video. We are looking at lesson 8.4, which is finding volume and surface area of spheres, and it starts on page 41. So if you haven't done so, would you get that ready? One thing I want you to do is take your pencil and we are going to write the formula for finding the volume of a sphere and the surface area of a sphere. I always like to write the formulas just so I have them and can look at them. So the volume is 4/3 times pi times the radius cubed. And remember, the radius cubed is the radius times the radius times the radius. Surface area is 4 times pi times the radius squared. And again, volume measures how much stuff it holds. Like if it were a container, how much it can hold inside. Surface area measures how much space the outside faces take up. So it's kind of like if you want to wrap it or if you want to paint it, how many square inches, square centimeters will you cover? Well, let's get started. Remember, for this practice, you may use a calculator. And we're going to use 3.14 as an approximation for pi. It says to round your answers to the nearest tenth if necessary. And one thing I've told classes, when we use our calculator, if it asks you to use 3.14 for pi, I want you to use that even if your calculator has a pi button on it. So let's look at the first part. Says find the volume of each solid sphere. So we're using this formula. So number 2 says it's a sphere with a diameter of 18. Well, if we look at the formula for the volume, we don't need the diameter, we need the radius. So we need to cut that diameter in half. So I'm just going to write r equals 9 to remind myself that the radius is 9. So let's write our formula and then we'll fill in what we know. So again, the formula volume is 4/3 times pi, but we are going to use 3.14. So I'm going to go ahead and write it with 3. Oops, times 3.14 times, and the radius is going to be cubed. So we're going to have 9 cubed. Okay, so this is quite nice. We can use our calculator. One thing I want to mention, clear that out, is if your calculator does not have a fraction button, what you can do is do 4 divided by 3 times 3.14 times 9 cubed. And to raise it to the third power, this little caret right here means raised to the third power. But if you don't have a fancy calculator and you need to, and you don't have, you can't raise it to a power, you could do 9 times 9 times 9. So I'm going to pretend that this is not a fancy calculator. So 4/3, instead of writing it as a fraction, we'll make it a division problem. 4 divided by 3. So I'll do 4 divided by 3 times, and then it says 3.14. 3.14 times, let's say 9 to the third power. Let's just do 9 times 9 times 9. And that equals 3052.08. The directions did say to round to the nearest tenth. So we are going to, this is what we got, 3052.08. This is the tenths place. This does the talking. So do we leave a 0 in the tenths place or put a 1? Well, we are going to put a 1. So the volume is 3052.1. My unit is centimeters. Volume is a cubic measure, so it's centimeters cubed. So that is your answer for number 1, or 2, excuse me, 2. All right, let's look at number 3. I just wanted to give you a quick hint on number 3. We're not going to do all of it together. but it says a puzzle is in the shape of a globe. The diameter of the globe is 7.6 centimeters. What is the surface area and then what is the volume? So you're going to use both of our formulas. The hint is, remember, for both of them you need radius, and radius is half of the diameter. So you've got to take 7.6 and divide it by 2. And if you were to divide that by 2, you would get 3.8. So the radius is 3.8 centimeters. All right, let's go down to number 5. Number 5 says, if a marble has a surface area of 2.25 pi square centimeters, what is the radius of the marble? Okay, so surface area, again, the formula for surface area, I'm going to write that down, is 4 times pi times the radius squared. So it is going to be 4, actually, I'm getting ahead of myself. So let's put in what we know. And what got my attention is the use of pi in the problem. Because pi is in part of the problem, we're finding an exact answer. And I'm kind of excited when I see that because I can just leave that as a symbol and I don't have to use 3.14. And I'll show you what I mean. Okay, so let's put in, this is our formula. Let's put in what we know. We know that the surface area is 2.25 pi. So I'm going to write 2.25 pi. That's the surface area. That's this. And that equals 4 pi. Do we know the radius? No, we do not. The radius, so we need the radius squared. Okay, so we are solving for the radius, which is right here. It's 4 pi is almost our coefficient. So if we divide this by 4 pi, that will leave just the radius squared. But if I divide the right side by 4 pi, I've got to divide the left side by 4 pi. That cancels out, and that leaves the radius squared. Now, the nice thing here is pi gets canceled out. So now we have 2.25 divided by 4. So I'm going to take my calculator, and I'm going to do 2.25 divided by 4, and I get 0.5625. 0.5625. Okay, here is the tricky part about this problem. The radius is squared. I don't want it to be squared, so I have to unsquare it. So how do I unsquare the radius? Well, I find the square root. But if I find the square root of this on the right side, I have to find the square root on the left side. One thing I want to mention, when it says to round to the nearest tenth, you really need to save the rounding until the last step. So use the numbers you have, but at the very end, round them. All right, so let's get our calculator. Now you do need to have a calculator with the square root function on this. And phones do have the calculator. My phone is an iPhone and I have to turn the phone to the side and it will access that. But on my calculator, I'm going to access the square root sign. And then I'm going to put 0.5625, enter. And that is 0.75. So the square root of the radius of radius squared is radius. The square root of 0.5625 is 0.75. So that means the radius is 0.75. The unit is centimeters. And radius is a linear measure, so it's just centimeters. All right, that is number 5. Number 6, you're going to do on your own. Number 7, let's do together. It says, focus this a little bit. See if that gets a little better. Kyle cuts a clay sphere in half to get 2 hemispheres. He measures the circumference of the hemispheres to be 31.4 inches. What is the radius of each hemisphere, and what is the total surface area of one of the solid hemispheres? Okay. If Kyle cuts a clay sphere in half and gets 2 centimeters or 2 hemispheres, those hemispheres are going to match. They're going to be the same size. They're going to have the same dimensions. So when it says what is the radius of each hemisphere, it's going to be the same thing. And then what is the surface area of a solid hemisphere? Let's do A first. They give us circumference in our problem. They tell us the circumference. And so we need to figure out how we can use circumference. Now remember, circumference is pi times the diameter, okay? So if the circumference is 31.4 inches, we're going to put 31.4 for the circumference. Is pi, we're going to use 3.14 for pi times the diameter. So now we've got a nice little one-step equation. To find diameter, I'm going to divide this by 3.14, and I'm going to divide this side by 3.14. That cancels out, leaving the diameter. 31.4 divided by 3.14 is 10. The diameter is 10. But A does not ask for the diameter. A asks for the radius. And if the diameter is 10, then the radius is half of 10, which is 5, and it is inches. The radius is 5 inches. All right, that's A. Let's look at B. B says, what is the total surface area of one of the solid hemispheres? Okay, the hemisphere has 2 parts to it. If we're finding the surface area, again, we're finding the outside. It's almost, a hemisphere is like a dome. So we've got the area of the curved part of the half circle or half a sphere. And then we've got a base, and the base is a circle. So we got to find the area of half of a sphere and the area of the circular base. Okay, so the surface area, I'm just going to write down kind of what we just said, is half the sphere, the surface area of the sphere, plus the area of the circle base. And the circle base is flat, so we'll find the area of that. All right, so we've got half a sphere, and remember, to find the surface area of a whole sphere, okay, just write it here. So we remember is 4 times pi times the radius squared. Okay. If the whole sphere is 4 pi r squared, half the sphere would be half as much. So that would be 2 pi r squared. Plus the area of the circle base. How do you find the area of a circle? It is pi times the radius squared. So that would be, so this is what we're using to find the surface area. This is the surface area of the half of a sphere, and this is the area of the circular base. Now, if you look at this, we've got 2 pi r squared, and this is another pi r squared. So we have in total 3 pi r squared. And let's put what we will put in our calculator. We're going to do 3 times pi, we're using 3.14, times the radius is 5, so it's 5, not squared, cubed squared, 5 squared. And 5 squared is 25. I'm just going to substitute 25 for that because we can do that in our head. All right, so let's take our calculator. And we're going to do 3 times 3.14 times 25. And that equals 235.5. 235.5. Our unit is inches, and area is a square measure, so it needs to be square inches. All right, so there you have it. We have done several together. I want you to do the remaining problems on your own, and you all have a great day. Talk to you soon. Bye.